For most school administrators, campus communication is a constant friction point. While 73% of institutions view digital signage as essential for their future, the path forward is often blocked by tight budgets and limited IT resources. This creates a difficult choice. Schools either have to commit to expensive corporate software licenses that charge per screen, or they have to stick with the manual, outdated routine of printing and stapling paper flyers. There is a third option that avoids both extremes. It involves using open-source Linux software running on highly affordable microcomputers, specifically the Raspberry Pi. However, the mention of Linux often triggers two specific concerns for IT managers. They worry the technical complexity will be overwhelming, and they doubt such inexpensive hardware can handle 24/7 operation in a school environment. To evaluate these options fairly, we have to look past the initial price tag. This chart maps the effort required against the actual student engagement you get in return. Choosing the right system means finding a solution that respects an administrator's time, the school's budget, and the security of the campus. We're putting the three most common methods into a direct showdown: traditional analog paper, the USB stick on a TV hack, and the Linux/Pi architecture. We will judge them based on three factors: speed of campus updates, inherent security risks, and 5-year total cost of ownership. In a school setting, total cost of ownership is the only metric that reveals the truth. Upfront hardware costs are often a deceptive distraction from the real budget impact. While a screen is a one-time purchase, the hidden, recurring costs of manual labor, hardware maintenance, and physical supplies are what actually drain a school's resources month after month. Any system that fails to reduce the daily workload for your staff ends up being a financial liability, regardless of the low price you paid on day one. Maintaining paper notice boards requires a constant physical workflow. Someone has to design the flyer, print it, replace the toner, laminate the page, and then walk across the entire campus with a staple gun. Schools stick with this because it's familiar. It requires no technology budget and no specialized training for the staff. But that familiarity comes with a high operational expense. Between the cost of physical supplies and the hundreds of hours of administrative labor, a medium-sized school bleeds significant resources over a 5-year period. Most importantly, analog boards offer zero utility during an emergency. When a campus goes into lockdown, a paper flyer cannot provide the instant visual instructions needed to guide students in noisy hallways or cafeterias. As the matrix shows, the analog method creates a massive labor drain and a total communication blackout during a crisis. It results in slow updates, high security risks, and a high 5-year cost. Then there's the USB hack. A school buys a consumer television, plugs in a flash drive full of images, and sets it to loop. This is a popular shortcut because it looks modern, but allows the school to completely bypass network integration and software setup. The flaw is that it doesn't scale. To change one announcement, a staff member has to walk to every screen, remove the drive, update it at a computer, and walk back. That's up to 30 minutes of manual work per screen every single time. It also leaves a physical security hole. Exposed USB ports on unmanaged TVs are easy targets for student tampering, allowing anyone to spot content or introduce malware into the school's devices. In our matrix, the USB method is revealed as an insecure band-aid. It creates the appearance of digital modernization while actually increasing the manual workload for the administration. The professional alternative uses a $35 to $75 Raspberry Pi paired with an open-source Linux management system like Xibo or Anthias. This store and forward mechanism addresses network congestion. The central server pushes the media file to the local Pi player exactly once. After download, the screen plays from local storage. Even if the internet drops, the content loops without interruption. To lock the system down, the Linux OS is configured into a read-only kiosk mode. In this state, any attempted tampering or system errors are temporary. Because the storage is read-only, any unauthorized changes are completely wiped the moment the device reboots, keeping the network stable and predictable. Decentralized Linux players solve the problems of network strain and external tampering natively, providing a controlled, secure environment for every screen on campus. For the school secretary or staff, the system is managed through a web dashboard that is as simple to use as common graphic design tools like Canva. This shifts the entire workload. A single person can instantly push an announcement to 50 screens across the campus with a few clicks, eliminating the need to ever walk a paper flyer or a USB drive down a hallway. The only real investment required is a brief training session to help staff get comfortable with the new interface and move past their hesitation regarding the word Linux. There is also an efficiency gain in energy. A Raspberry Pi runs on just 3 to 5 watts. Compared to the chemical waste and carbon footprint of the paper production cycle, the digital shift is significantly more sustainable. Open source Linux replaces the manual friction of the previous methods with an automated network. It secures the highest grades for update speed, security, and long-term cost. The financial reality is stark. When you factor in the labor and supply costs of paper, staying with the analog status quo is actually the most expensive choice a school can make over a 5-year period. As the data suggests, the open-source Linux/Pi system is the only option that successfully lands in the high-engagement, low-effort quadrant. Beyond the financial savings, these powerful digital systems address the absolute fundamental priority of any educational institution: physical student safety. These screens can integrate with emergency APIs and early warning systems. In a sudden crisis, every single screen on campus can be overridden instantly to show evacuation routes or lockdown protocols, reaching students precisely when seconds are critical. The true value of an open-source system is reclaiming total control over your communication, ensuring the school can protect and guide its community at a moment's notice. Transitioning to Linux is a matter of choosing the right software tier for your specific scale. For small primary schools or solo administrators managing just a few screens, the best choice is Anthias software running on a Raspberry Pi. Anthias software focuses on extreme plug-and-play simplicity, making it perfect for users who don't need complex permissions or multi-user management. For large high schools or major university campuses with complex multi-building networks, Xibo running on Ubuntu is the standard. This decision tree highlights the split. While Xibo has a slightly steeper learning curve for IT, it provides the advanced zoning, multi-user controls, and emergency integrations needed for complex environments. By adopting open-source digital signage, a school escapes manual labor and recurring fees, entering an era of secure, instant, highly engaging communication.